Hello everyone, welcome to my channel Chemistry is Fun. Today we will be dealing with a new topic which is related to the chapter on hydrogen. That is, we will study the physical and chemical properties of water and heavy water. Heavy water, as we will see, has deuterium. So it is having some dissimilar physical and chemical properties than normal water. Now first we will have a look into the physical properties of normal water. As we all know, pure water is colorless, tasteless and odorless. That we have seen, it's common and we all know about it. It will freeze at 0 degrees C and boil at 100 degrees C. Its maximum density is 1 gram per centimeter cube at 4 degrees C. So it is the maximum density for normal water. If you see the molecule, it is a polar molecule and its structure is V-shaped. H2O, that is HOH. The actual molecule is HOH, V-shaped molecule. The bond angle will be 104.5 degree. And it is a very good solvent for polar and ionic substances because water is a polar molecule. So it can dissolve polar. We know like dissolves like. So if polarity is there in some molecules, it will dissolve in water. Its dielectric constant is very high, but it is a poor conductor of electricity. Therefore, we all know that in order to increase the conductivity, we can add some dilute acid or a base or some salt. In liquid state, it will exist as associated molecule by hydrogen bonding. So water is H2O, that is HOH bond. So hydrogen bonding will be present between the oxygen of one molecule and the hydrogen of the other molecule. That gives rise to association. Hydrogen bonding is only responsible for very high value of specific heat for water. If we see the chemical properties of water, water is neutral with exact pH value of 7 and it can react with active metals. While doing so, it evolves hydrogen gas. For example, sodium, calcium, these are active metals. They react with water. The metal hydroxides will be formed and hydrogen gas will be evolved. When it reacts with non-metals like fluorine, fluorine can decompose cold water. While doing so, it decomposes in two ways. If it reacts in the ratio of 1:1, we get oxygen liberation. Whereas if three molecules of fluorine and 3 water molecules react, we get H2F2 along with ozone. So overall we get ozonized oxygen as the product. So this is about fluorine. Chlorine can decompose cold water. When it does so, it forms HCl and HClO, that is hypochlorous acid. Chlorine reacts with water to form HCl and hypochlorous acid. But if the reaction takes place in presence of sunlight, we will get hydrogen chloride HCl and oxygen molecule will be formed when the reaction takes place in the presence of sunlight. Another non-metal, carbon, in the form of coke. If we take red hot coke and steam, we get water gas, which is a mixture of carbon monoxide and hydrogen, CO plus H2. Water gas is produced. Non-metallic oxides like carbon dioxide, SO2, SO3, all such non-metallic oxides, they are acidic in nature. So they react with water to form acids like CO2 will form carbonic acid, H2CO3. SO2 will give rise to H2SO3. SO3, sulfur trioxide, produces sulfuric acid, H2SO4, as we know in contact process. N2O5 will give HNO3, nitric acid. So the acidic oxides with water give rise to acids. Metallic oxides give rise to alkalis. Metallic oxides are the oxides of metals like the elements of alkali metals or alkaline earth metals. Sodium oxide and water forms NaOH. Similarly, calcium oxide, which is a metallic oxide and basic in nature, will give rise to CaOH twice. So we get alkalis in these cases. If hydrides or carbides or nitrides or phosphides, such molecules of such compounds, if they react with water, we will get different types of evolutions. For example, if it is hydride like calcium hydride and water, we will get hydrogen gas. Whereas calcium carbide CaCO2 will produce acetylene C2H2. In both the cases CaOH twice is produced. Nitride will give rise to ammonia like magnesium nitride and water gives rise to magnesium hydroxide and ammonia is produced. Whereas phosphide, calcium phosphide and water gives rise to calcium hydroxide and phosphine. So depending upon what type of molecule or what type of compound we are taking, we get the evolution of gases. It may be hydrogen gas or it may be acetylene or it may be ammonia or phosphine. The different products formed are different. Water also gives rise to hydrolysis of salt. If you take sodium acetate CH3COONA, which is a salt of a strong base and a weak acid, on hydrolysis we get back the acid, acetic acid and NaOH, sodium hydroxide, which is a strong base. Some of the salts like BiCl3 will give us oxy compounds like we get bismuth oxychloride BiOCl and HCl will be produced. Some nonmetal halides like phosphorus pentachloride, they were decomposed by water. In that case, like if I take PCl5 and water, we get H3PO4 and HCl. If I take SiCl4 and water, we get H2SiO3 and HCl will be produced in both the cases. Strong acid is getting produced means if it is a chloride, we definitely get HCl. Decomposition of water can take place like when we do the action on alkali or acid. Water which is having alkali or acid, when it is electrolyzed in the presence of electricity, it gets decomposed into hydrogen and oxygen, and that is the components we get back. In some of the salts we find that there is some water molecule associated with them. The water which is present in the hydrates is called as water of hydration or water of crystallization. Like in copper sulfate CuSO4.5H2O, there are 5 molecules as water of crystallization, whereas in magnesium sulfate it is 7 molecules of water of crystallization MgSO4.7H2O. So these are all about the properties of normal water. If we have a look at the physical properties of heavy water is actually deuterium oxide. In my previous video I have told you that there are 3 isotopes of hydrogen: protium, deuterium and tritium. The deuterium part, if we use, that oxide is known as heavy water. Physically, if you see, it is also colorless, odorless at room temperature, but its melting point is 3.82 degrees C. Melting point for heavy water will be 3.82 degrees C, whereas boiling point, see, these are not like normal water, it is different. It is 101.4 degrees C, 101.4 degrees C. At STP, the density will be 1.1056 gram per ml, which is little bit high than normal water. If you see the pH for heavy water at 25 degrees C, it is 7.44. As we have just seen some time back, the pH is exactly 7 for normal water. So we conclude that its density is greater than normal water, but it can form a homogeneous mixture with normal water. If we see the dissociation, heavy water is less dissociated than normal water at any given temperature. At any given temperature. Now, because, and if you see the density, it is 10.6% denser. Now, if we go for the chemical properties of heavy water, we know that the chemical reactions it will also undergo, but the reactions where it is involved will proceed at a slower rate than normal water, because and it is less dissociated as well. If we do the electrolysis, heavy water is G2O, so it will break down into D2 and O2. we get deuterium. It is obtained at the cathode. When alkali and alkaline earth metals act upon it, we get dideuterium. Dideuterium will be obtained, but the rate is very slow. For example, D2O is heavy water acted upon by sodium. We get NaOD and dideuterium. The rate will be very slow. If we consider action of metallic oxides, the reaction is very slow and we get deuteroxides. Deuteroxides, Deuteroxides.